I am going to measure the voltage on the Tesla coil. To do this, I will have to first find the maximum reliable arc length. To do this, I increased the spark gap to be as long as I possibly could while still having reliable sparks. Then I measured the spark gap length. I measured the spark gap to be around 18 millimeters long. As the breakout voltage of air is 3000 volts per millimeter, this will make the sparks to be around 15,000 volts across the spark gap. The next experiment I'm going to attempt is to light a fluorescent lamp with only the Tesla coil. The high voltage of the Tesla coil creates electric field so strong that it can penetrate into the fluorescent lamp and cause the gas to glow. When I bring the lamp close enough, we can see some sparks jumping right into it. We can also see how the sparks can go right through the lamp and jump back to the other electrode. After running the coil for a while, I noticed that the center ferrite rod would heat up. This is how induction heating works, and it works because of eddy currents and possibly hysteresis because the material is magnetic. Next I took my NSD and applied the high voltage between two metal plates, in this case aluminium foil. Between the foils I put some regular table salt. The salt starts to move because of Lorentz force. First, some electrons of the salt particle are either stripped away or added to it, making it charge just a little bit. Then, the electric field will cause a force proportional to the strength of the electric field and the charge of the particle. This experiment would show the force even stronger with DC voltage, but now I used AC voltage because I didn't bother to put any diodes in between. Next, some spoilers of my upcoming projects. Here we have a lonely 63 volt and 10,000 microfarad capacitor. Yeah, right, it's lonely. Of course I have fucking bunch of them. So, what would you like to see me do with them? A coil gun? A spot welder? A deadly electric chair? Who knows? Let me know in the comments. And here's the probable future Tesla coil power supply. 2 MOTs. I haven't decided yet whether I'm going to use another one of these as a ballast or use 2 of these to create the voltage and get a third one to be the ballast. Either way, there's going to be a deadly amount of power in the future Tesla coils. I'm scared. If I'm not going to use the MOTs, I'm going to use this. This is a self-wound secondary coil for a high voltage transformer. It has 2530 turns of 0.6 mm enameled copper wire, and after submerging it in oil, it should be able to take around 20,000 volts. I only need a vacuum chamber and the oil. Then I'm going to make a video about it. Subscribe to this channel to be the first to know when it happens. Of course, not everything I do is about high voltage. Here I have my 30-ton bottle jack that I'm going to use to create a press that I'm going to use to squeeze some materials. Let's see how that will end up. If you're still watching this video, my greatest thanks. I hope you enjoyed. See you next time.